Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 3 today, looking at Section 3.2 on graphing linear equations. In this section, we will identify linear equations and graph linear equations by finding and plotting ordered pair solutions. And just like in the last section, we will be constructing graphs of linear functions. All right, so when we talk about a linear equation in two variables, that's an equation that can be written in the form ax plus by equals c, where a and b are not both zero. So understand that in any given problem, a, b, and c will be given real numbers. X and y will be variables. So for example, y equals x minus 15 is a linear equation. You can rearrange that equation so it's in this form, for example, by subtracting x on both sides. That would give you negative x plus y equals negative 15. This is not a linear equation because y is raised to the power 3. So one requirement for a linear equation is that x and y are only to the first power. This is a linear equation. It's in exactly the right form. A is 0.01, B is negative 0.2, and C is 8.8. And believe it or not, this is also a linear equation. This one can be written in the form 1x plus 0y equals 25. All right, so in this section, we're going to look at the first of several methods for graphing linear equations. And that method is to find ordered pair solutions. We generally recommend finding 3 ordered pair solutions. So in this example, we're going to be looking at the equation y equals 1/2 x. Notice that they've given us a table that's already been started. So we will complete that table the way that we did in the last section. And then we'll plot those ordered pairs and connect the dots. All right. So switching over to the tablet. Okay, remember how we did this in the last section? We're going to replace x with 0. I'm just going to go ahead and start my work here. Okay, so 1/2 times 0 is 0. 1/2 times negative 4 is negative 2. And 1/2 times 2 is 1. All right, so that means we're going to be using the ordered pairs 0, 0, negative 4, negative 2, and 2, 1. All right, so there's 0, 0. Remember, negative 4, negative 2 means go 4 to the left and 2 down. So that would put us right here. And finally, 2, 1 means go 2 to the right and 1 up. Okay. Notice that those points lie in a straight line. And that's what all of the graphs of these linear equations are going to have in common. They're going to be straight lines. The reason that we recommend finding 3 ordered pair solutions, technically you only need 2. Think of that third point as a checkpoint. You want to make sure that the 3 points line up. So what usually happens if you make a mistake is that one of the points will not line up, and then you know that you made a mistake somewhere and you can go back and fix it. All right. Now, I have to warn you, I am much better at drawing straight lines on a piece of paper or on a whiteboard than I am on a tablet. And I don't think, all right, I'm going to try something here. Bear with me. Okay. I'm using a straight edge here. It's a box. And so it's going to take me a little bit of practice to line up the box so that I get the line in the right place. Okay. Well, that's, I think, good enough. Right. I will probably get better at this as I practice more, but that's the idea. All right, let's go back to the presentation. Okay, you might be able to hear my cat there saying hello. All right, so as I mentioned, we'll be looking at several different methods for graphing linear equations. The point plotting method is the one we just used. As we move through this chapter, we will talk about two other methods to be determined. I don't always keep people in suspense, but when I do. All right. Next examples. So very similar to the last example, only this time they did not give me the table. I have to come up with the table myself. And I've noticed that students sometimes freak out a little about this, but it's really not that hard. So let's go back to the tablet. Okay, for the first example, which is y equals 1/4 x plus 3. So again, they didn't give me the table. I have to make the table myself. All right, so I have a suggestion, which is to make a table that's similar to the one we used in the last example. So for example, x equals 0 is usually a good choice. Notice that the first thing I'm going to have to do to x is multiply it by 1/4. So my suggestion is that you use multiples of 4. If you don't use multiples of 4, your y values are going to come out as fractions, which is sometimes unavoidable. But in this problem, it is totally avoidable. So for example, x equals 4 and x equals -4 are really good choices. So here I'm going to write 1/4 blank plus 3, 1/4 blank plus 3, 1/4 blank plus 3. All right, so when x is 0, 1/4 times 0 is 0. 0 plus 3 is 3. 1/4 times 4 is 1. 1 plus 3 is 4. And 1/4 times -4 is -1. -1 plus 3 is 2. So this time the ordered pairs I'm going to be using are 0, 3, 4, 4, which means go 4 to the right and 4 up. And then -4, 2. Oh dear. So far on the tablet, I haven't found a good way to put in the grid and also leave a little blank space around it for my written work. So this is a thing that may happen sometimes. All right. Okay, so now I'm going to try again to draw my straight line and try to get it through these points. Okay, well, that might be a little better than the last one. What do you think? All right, so that is the graph of y equals 1/4 x plus 3. Okay, the next example is interesting. X equals -1, so there is no y in this equation. So you go to draw to make the table for that, and you might get a little stuck, wondering what to do. I mean, it just says x equals -1. Well, the meaning of x equals -1, or, even if it was like y equals 2 and the x was missing, is x is always -1. And y can be absolutely anything it wants to be. Y could be 0, y could be 2, y could be -3. Okay. All right. So if I go to plot those points, -1, 0 means 1 to the left, but don't go up or down. -1, 2 means go 1 to the left and go 2 up. -1, -3 means 1 to the left and 3 down. All right, so notice that those points are all, well, they form a vertical line. All right, let me try this again. All right, I think that's the best one yet. Okay, so little piece of information to keep on the back burner there, that x equals -1 made the graph of a vertical line. And we'll talk more about that in a future section. Let's go back to the presentation. So I believe this is the last example. Graph the pair of linear equations on the same set of axes. Discuss how the graphs are similar and how they are different. Okay, so back to the tablet one last time. Okay, so this time I will make two tables, one for y equals 2x. All right, so we could just go 0, 1, 2. That would be fine. 2 times blank, 2 times blank, 2 times blank. All right, 2 times 0 is 0. 2 times 1 is 2. Oh, before I go any further, I should say this again. At any time when you want to try a problem ahead of me, I totally encourage that. Please pause the video, try it, and come back and compare notes. All right. I think this particular problem is one that I often do that when I'm teaching a face-to-face class, and they usually do pretty well with it. Okay, so if you want to finish the problem at this point, go ahead and pause the video, come back when you're ready. Okay, so 2 times 2 is 4. So this line passes through the points 0, 0, 1, 2, and 2, 4. Okay, just thought of something. Yeah, okay. All right, so this line is going to look something like, I want to try that again. See, I raised the bar for myself with that last one. That last one came out really good. Okay, that's better. Okay, now y equals 2x plus 5. I'm going to do a little something different with this one, and I'll explain why in just a second. Instead of x equals 0, 1, 2, I'm going to do 0, -1, -2. And I'll just go ahead and tell you now why I'm doing it that way. This grid only goes up to y equals 6. And so if I use x equals 1 and 2, those points are going to be off the grid. Okay, so that's something that I am going to have to worry about a little bit later. Okay, bear with me. I'm just making a little more space in this table because I'm running out of room here. Okay. 2 times 0 plus 5, or I should say 2 times blank plus 5, 2 times blank plus 5. All right. And let me do this. Oops. Okay. 2 times 0 is 0. 0 plus 5 is 5. 2 times -1 is -2. -2 plus 5 is 3. 2 times -2 is -4. -4 plus 5 is 1. All right, so here is 0, 5. -1 comma 3 is right here. And -2 comma 1 is right about there. All right, so when I draw this graph, comes out looking something like that. Okay. All right, so they had asked me, how are the graphs similar and how are they different? Well, maybe start with how they're different. They go through all completely different points, right? But, and I'm trying to think how you would say this at this point. Do you see what they have in common? Well, I'll just go ahead and get a little ahead of myself. They have the same slope. They are going up at the same rate. Okay. So they want to get us thinking about slope, which they won't be talking about for a few more sections, or I think 2 sections from now. They'll talk about slope. Okay, so similar. They have the same slope. But how are they different? They go through totally different set of points. Okay, and you will probably have a problem like this in your homework, and I would imagine that the how are they similar and how are they different is probably going to be a multiple choice question. And I don't actually know what the choices are going to be, but you should be able to pick the correct ones. And that's going to do it for section 3.2. We'll see you next time.